So if we look at this very well, you see that this is a repeated root case. I want to want to use the parallel form to solve this. So what we'll do is we'll say a all over s plus 1 squared, then plus b all over s plus 1, then plus c all over s plus 2. That is being repeated root, so we have to continue to decrease the power like that. So to get a, we just use, let's call this one t of s, so that this will become t of s into s plus 1 squared. That is the what's it called, denominator of a. That's what we put there. S, we now put, equate this one to 0 and find the value of s, which is minus 1. So that's an attempt to get a. When you multiply this one by ts, that is, you are multiplying this entire fraction expression by this one. So this will cut this. You will left to this and this. So you have s plus 3 all over s plus 2. So where s is minus 1. So you put minus 1 into there, and in minus 1 plus 2, then minus 1 plus 2. So minus 1 plus 3, that's 2. And that's 1. So you have 2 there. So to get b, since it's a repeated root, so the subsequent one anytime we want to find the subsequent one, we need to differentiate whatever we have here. So this expression, this particular value that is here, you have to differentiate it to get b, because it's still the same s plus 1 that is there. So we do d ds of this particular expression, that is s plus 3 all over s plus 2. So the first one we do, it has to be the one with the highest power. This one is the one we will not differentiate. But the second one that will reduce its power to 1, so we will now differentiate it. So that's this one we are differentiating now. So when we differentiate this, we are using the quotient rule of differentiation to just to solve this. So we use v du ds plus minus u dv ds all over v squared. You know that formula for differentiation. That is when the y ds, when y is equals to u all over v, then the y ds is equals to v du ds minus u dv dx all over v squared. This is quotient rule. We call it quotient rule. That's what we are going to use here, since it's this over this. So we can now have s plus 2, which is v, then du ds, which is when you differentiate this is 1, minus u, which is s plus 3 dv ds, and that is this 1 all over v squared, which is s plus 2 squared. So that is going to give us, so we now put our s equals to minus 1 here. So when we put s minus 1 here, so we have minus 1 plus 2, then minus 1 plus 3 all over minus 1 plus 2. So that's going to be minus 1 plus 2, that's 1, minus, this is going to be 2 all over 1, right, squared. So that's 1 minus 2, that's minus 1 all over 1, which is minus 1 eventually. So that's how b is obtained. So to get c, so we just do the third one. It does not have anything to do with this one, so we just do it separately, which is going to be ts s plus 2. That's it. Whereas is equate what is here to 0, you find the value of s, which is minus 2. So that means you are multiplying this entire fraction with s plus 2. So this will cut that s plus 2. You are left with s plus 3 and s plus 1 square. So s plus 3 all over s plus 1 square. So at this point, you now substitute minus 2 there. So minus 2 plus 3 minus 2 plus 1 square. So that's 1 all over minus 1 squared. And that's 1, right? So at this point, so what we do now is now bring everything together. So our TS is now equal to what's that? A, which is 2 all over s plus 1 squared. Then B, which is minus 1, right? So minus 1 all over s plus 1. Then C, which is also 1 all over s plus 2. So now that we have this now, we have this expression now. So the next thing we want to do is to now represent them. Now this one that has power 2. So what we do here is represent it in 2 places. You know, that's minus 1 here. This minus 1 is here. So this is the 1 over s. Then we also represent it in 2 places. You see? So minus 1 over s. I believe that is clear, right? So we join them together with 1 as the joining point. Then this one, which is having this one, since this one is also this one, you get it. But this one with power 2 is what we are representing here. So we are whatever we want to get, if we want to extract this one from here, we'll be extracting it from one of these two. So this s plus 2 is gonna be here. So at this point, we'll now connect all of them together. So this one also connects them together. Now, as we connect them together, we want to get our R, and this is our S, our C rather. Now we call this one X1. This will be S1 dots. This is X2 dots. Let's call this one X3. This is X3 dots, right? Now we want to link this one with input to the output. Now, if you note this one now, this is to obtain C of S. If you note this thing, you know that this is the same thing as this particular expression. I just want you to see that C of S all over R of S is equals to 2 all over S plus 1 squared minus 1 all over S plus 1, then plus 1 all over S plus 2. So this C of S that you are looking at is the same thing as 2 all over S plus 1, everything square of R of S, right? Then minus 1 all over S plus 1 of R of S, then plus 1 over 2, 1 all over S plus 2 of R of S. You can see that that's R of S. If you want to represent these two, that's these two that they are put here. These two here. 2. If you want to link this input to the output, this C of S is equals to 2 multiplying R of S here. It should now go. Then it first S plus 1, which is S plus 1 here. Then the second S plus 1, it goes to the second S plus 1. Right? Then it links to the last one, which is this 1. So that's how we link this input. If you want to trace this one out, this first term, this first term here, this is 2 times 1 over S plus 1, another 1 over S plus 1, then times 1. It should give us the output. Is that clear? So that's the first one. Then the second one, this second one that we want to get now, which is this one, is supposed to be 1, because what we have here is minus 1 over S plus 1. So we have to find a way to get it from this expression. And this must link with the input as well, with their inputs. So it will go from here. 2 is here, so we cannot remove it. So we have to find a way to divide it with something so that it will eventually become minus 1. You understand me? So it has to go from here to that is 2 multiplying. It must be This is 1 all over s plus 1. So we now draw this one to link it to the outputs. Do you get it now? Because it has to, we have to represent this one too. It has to be represented because it has a link with the output. So we have to link it from here to the output. So since 2 has already multiplied it from here, then that 2, we need to find a way to what? To remove that 2 so that it will become minus 1 that will eventually multiply it. And that will now be this 2 divided by 2. So that will now be, we use minus half, right? So when minus half multiplies this one, you have minus 1. So that means if you trace this one from the inputs, you will see that it will go like this, and eventually it will become minus 1, which is exactly what we want to see here, which is minus 1 RS. And for the third one, it's just simple. This is 1, so it's just going to be 1 here. So 1 multiply everything, and it's 1. So 1 will just multiply everything all through. So that's how this one is obtained.